So we did platelets. We got didn't quite get to the last part. So we spend too much time talking about blood type and babies.
Yeah, the blood type throws for a reason.
Always does. Oh, I don't know if there's something in the air lately, but my eyes, like every day, there's been feeling like so messed up. And is this one still all red over here?
Yeah.
Yeah. Yeah, I feel like I'm like, maybe it's allergies or something just hitting them. I don't know. I feel like swollen too. Anyways.
I was going to say eye drops. Yeah. Maybe some allergy pills.
Or some neti pot. Neti pot. All right. So let's go ahead and finish up our blood clotting so we can get to the fun heart. So if you remember, there was 3 stages of hemostasis, of like preventing blood from leaking out of your vessels. What was the first one? Starts with, so vascular spasm, which is the blood vessel closes up a little bit. What was the second stage? So second is platelet plug. That's the ones we already talked about. Third one is clotting, which we didn't get to. So that's kind of where we're at. So one of the cool things about how blood clotting works is basically your blood's full of all these clotting factors, but they're not activated. They're just kind of floating around. Just like you've got platelets floating around all over. The reason they do it that way is so whenever some vessel is damaged, that means you've got what you need to fix it right there, because it's everywhere the blood is. That's a lot faster and more efficient than waiting for the damage to happen and sending a signal somewhere, like to an organ, and the organ has to make something to send it there. That would take way too long, bleed too much. So instead, you send everything around in an inactive form, and then it can get activated when it's needed. So all the clotting factors are like proteins, enzymes, and they've got little Roman numerals behind them, like factor 8, factor 12, factor 7. And unfortunately, you would think maybe they'd act in order, like factor 1 gets activated, and then factor 2. But that would be too logical. So instead, how do you think they numbered them? How does that always work in science?
In order of how they were discovered?
Yeah, in order of how they were discovered, of course. And once it gets a name, you can't change it, right? Because then everybody would be really confused. Like I learned it was factor 8. Oh, we're going to call it factor 1 now. Wouldn't work. So we kind of divide it into 2 different pathways, depending on basically how severe the injury is. So extrinsic and intrinsic are our 2 sort of stimuluses that activate the whole clotting pathway. The first one is kind of like the one we've been talking about, the intrinsic. So that's like a pretty mild damage to the blood vessel where you had it. It's not like you got stabbed through the kidney or something. Just a small little break in the blood vessel, so it exposed the collagen, but not deep into the tissue, just kind of a mild one. And you remember that activated platelets on the side, and also factor 12, or XII, is activated by the collagen as well. It combines with calcium to activate factor 10. Factor 10 and 5 come together to make prothrombinase. And then everything after that is what's called the common pathway, which we'll talk about in just a second. And it's common because it's activated by both of these two. If you get a more severe injury, where you actually get damage to the tissue around the blood vessel, like the lung, the heart, the liver, whatever it is, those cells release something called tissue factor. It's there to very rapidly activate this whole pathway. So it goes right from tissue factor to activating factor X. Combines with V to make prothrombinase, and then it's common after that. So extrinsic, fewer steps. It's a more rapid, faster response to make a blood clot. And then we stop the prothrombinase. Anything with an ACE, what does that mean? It's an enzyme. And prothrombinase, it acts on prothrombin. Just tells you in the name what it does. Prothrombin is turned into thrombin by prothrombinase. And then thrombin is actually the enzyme that turns fibrinogen, which is the inactive, like raw materials to make a blood clot, into fibrin. And fibrin's what actually makes the clot itself. Like it's the collagen, well, I guess it's not collagen, it's fibrin, but it's like the little ropes that get tied around the hole. And first it's laid down loose. And after it gets laid down, it kind of automatically shortens all those little ropes you put around the hole. And so as it shortens, it's going to grab more red blood cells, pull everything back together, and create like that strong clot that you would need. So there's a lot of stuff up there. All right, so I just put it in words too, in case you're studying it later. There's extrinsic, there's the intrinsic, and then there's the common pathway. And you can see the picture there. Here's kind of the very beginning where you're just starting to put down fibrin. Fibrin's in yellow. So that enzyme's activating fibrinogen, which turns it into fibrin. And then here's about medium way through. More zoomed in, which is confusing, I think. Or wait, no, that one's more zoomed in. This one's less. So you can see it's kind of thicker fibers even. And then they got completely tight and way more dense by the end of it, to where you can barely even see like the red blood cell behind it. Whereas before, it was like mostly blood cells, a little bit of fibrin, and then once it's complete, you've got the full mesh, fibrin mesh, to prevent the blood cells from leaking out. All right, so I'm going to have you practice with that. Which is number 4, which is, that should be like the compare and contrast one, right?
Yeah.
And as part of that worksheet, I did pass you out a diagram.
Can I get it?
Yes. And I'll also put that back up. I was just looking at the extra one. Who else wasn't here? Was somebody? Oh, whoa. Whoa. Oh my God. Okay. Anybody else? I need batteries. There's no room for here. So you may want to think about like what activates each one, what factors are involved, how fast they are. So fibrin's in both of them.
Yeah. Oh,
Oh, you put it in both.
because this one's loose and this one's strengthened.
No, look, everything ends in loose and strengthened. So everything from here and here is in both.
Oh, okay.
Yeah. So they both have blood clotting fibrin.
So make sure you're talking this over with your group. Make sure so you got a combination of everyone's brains. Come on, Alex. One word. You can do it. You can do it. It is. And it makes sense because it's a worse injury. So you'd probably want to clot your blood more intensely.
Sure. Yeah.
Getting some good stuff over here. Prothrombinase is in both of them, though.
That's the only time, only situation to answer with her GAS.
Which one?
On number 3.
Oh, they're all no.
Yeah, except for the one that you gave us an example of it was a yes.
Right,
And
which
that's-
is what I meant C to be, but I pushed minus instead of plus for that.
Okay.
That
So
first
that's
thing.
what's written. That's,
Yeah, no, I know.
yeah.
Sorry. I was worried maybe you didn't hear about the last one. I was like, oh,
But
no.
I didn't want him to be like, what is this written on here? Just, fun activity.
Yeah.
Just my extra stuff.
That's everything they have in common. So from the prothrombinase down, they have in common. Everything above that.
So what about some of the factors involved? Like tissue factor, which one does that go into?
Extrinsic.
And that would be what activates it, right? Well, you've got a lot of stuff written down over here.
I know. I'm kind of doing that, but I'm adding other things. like
That's awesome. Yeah.
Take it off, it's just like the book and stuff, but it's.
Yeah.
Yeah, but there's things you can put like one, like this one's more mild.
That sort of stuff.
This one's slower, it's fast.
Mhm. Yeah, and for
But that's what they
Like-
share.
you'll probably tell by now tests, it'd be like, choose 2 differences, 2 similarities,
Yeah.
you know, like a short answer, so you
I'm
don't,
putting like the little things and then I'm gonna read the whole thing.
right, yeah.
I do so much better in my own handwriting. I can't just read it.
Uh-huh,
Rewrite everything.
yeah, that helps.
Yeah.
I was like, no, you already wrote that.
So is it saying that this first step is activated by factor 12?
It's activated by collagen,
Oh, okay.
but you're right that 12 is only an intrinsic. Right, 'cause you don't see anything about it over in the extrinsic one.
I can't even spell it.
Activated by collagen.
Yeah.
Factor
Does
12.
it go on?
It's only activated by collagen fibers?
Yeah. Yeah.
Sweet.
And factor 5 is an eccentric.
What, so extrinsic, what activates the extrinsic pathway?
I did put factor 12
Tissue trauma.
Right, and exactly, it's tissue factor that's released from the damaged tissue. So it's activated by tissue factor. So y'all got there. All right, so we're just doing that one question for now. So it looks like everybody got some good stuff. Here's some questions for you. Can the intrinsic pathway be activated by itself? Like without the extrinsic one activated? It can. Can the extrinsic pathway be activated without the intrinsic? Why not?
Yeah, and extreme damage.
Well, so yeah, so I'm saying, can the extrinsic pathway be activated by itself without the intrinsic getting activated? The answer is no. Because if you have a severe damage to a blood vessel into the tissue, you're going to have exposed collagen.
So like intrinsic's gonna happen anyways. Yeah. And it just depends on how mild or the depth.
Yeah, exactly. Exactly. So when extrinsic's activated, intrinsic is going to be activated too. So you kind of get both pathways, which is also good because then it's even faster than extrinsic by itself.
Is that why it's more rapid?
No, extrinsic itself is more rapid, but if you add in intrinsic, it makes it even better. It's a pretty impressive system when you think about how much, how severe of wounds people can survive with no medical attention even. Like the guy that cut his leg off, right? Or was his arm? Wait.
Arm.
It was his arm, right? He didn't bleed out and die. His blood clotted and,
My
pretty crazy.
sister-in-law met him at a music festival.
Oh, yeah?
Dropping, hey, I'm that guy. Cut my arm off.
I wonder how it's probably a pretty good pickup line, imagine. Like, that movie? That's about me. I'm real tough.
I'm real tough.
It worked on your system. That's funny. It did, didn't it? Yeah, it would. All right. So obviously it's good to be able to clot your blood quickly and rapidly. So if you get an injury, you don't lose all your blood and die. But is there a problem of blood clots causing problems for people?
Yes.
And that would what can that cause? So strokes and what else? So like heart attacks would be the 2 main problems, and other things too. So there's got to be a good way to turn the system down, turn it off. And the first one is the fibrinolytic system. And this one's interesting because when you're making the clot, when the fibrin's getting put down, it also puts down an enzyme called plasminogen. And after it's in that clot for a while, once the clot's formed, it almost immediately gets turned on to start digesting the fibrin slowly. So it's kind of a mechanism of, we've got the fibrin clot, and that'll be present for, depending on the size of the tear, whatever, 24 hours, 72 hours, whatever. And then you're slowly digesting the fibrin while the tissue's repairing itself. So that when the tissue's repaired, the clot's dissolved, and it doesn't just release from the blood vessel and go float around and cause a heart attack or something. Oh, and I guess this is kind of missing. This should say plasmin dissolves fibrin or breaks it down. I must have just like fallen asleep when I was writing that slide or something.
You said plasmin dissolves fibrin?
Plasmin dissolves fibrin, which is what made up the clot in the first place. Anyone in medical terminology? Did you learn this suffix? Something that has GEN at the end? It probably wouldn't. Maybe that's not even in medical terminology. Any idea what this means? So it means an inactive form of a molecule. Right? So we've seen two examples already. Plasminogen is inactive plasmin. Fibrinogen is inactive fibrin. So when you see that, it means like inactive or so you see that a lot in stuff you read too. All right. So let's try this one. Do I have a copy of this? So 5 is basically, too much clotting, slower clotting, something like that. So once again, use that diagram to help you kind of see where things are happening.
I think if you had too many, it would just. Because you have more platelets.
Prothrombinase? It is a hard word to say, actually. I think M and B are hard to say together. Those two letters. Yeah. Like lamb.
Yes, like that.
Just like that. Can I get the lamb chops? I like that.
Yeah. It would just, you would just wait for longer.
You have low levels of
Factor X, but it'll, you have it, so you'll eventually want it to
I don't know.
where
Oh, yeah. Backdoor slide, breaks down. Slide will dissolve the fiber.
So maybe saying if it's going to make clotting faster, slower, what's it going to do to that? Do you know what I mean?
If the wasn't activated, then you would overbleed because it wouldn't clot.
Right, so not enough clotting, right?
And on the second one,
Yeah, because you're not activating the platelets to adhere to the collagen.
For B, what were you saying?
The drug that increases the amount of platelets in the blood, and we said exposed collagen in the damaged tissue.
So clotting faster, slower.
Could be faster. Slower.
And then it would.
Could be faster, wouldn't it? Because there's more.
Right, platelets do clotting, more platelets.
Oh, because it increased.
Yeah. So I think especially for these, even though a test or anything, you really got to read it like 2 or 3 times and make sure you're seeing increase or decrease. What's a platelet? So it's really easy to like just miss it or just like skip to what you think the answer is without really thinking about it. Do you know what I mean?
Yeah. I think where it says a drug, I think that
Yeah, that's
threw us
what's,
off.
yeah.
So you were thinking it'd be blocking something maybe? Yeah, some drugs increase stuff.
Well, I was just thinking to a drug, a pharmaceutical drug, yeah, not so much, the damaged cell right there, or we're thinking more of something you take.
It would be something you take.
Oh,
It would cause you to make more platelets. So if someone had like a disorder where they didn't make enough platelets, they can take a drug to make more.
Oh, okay, that makes sense.
But, this would just assume that like a normal person took that drug.
Okay.
Oh, the way I look at it is like,
Yeah.
the clot would be formed as it's dissolving, so I don't think you would ever form a complete clot.
Right.
I don't think you would
Might slow
ever.
down the blood flow though. I mean,
Yeah, but I think you would still bleed.
yeah.
I think you would have to do stitches or something like that on the outside to
Yeah.
actually stop it, to form a scab.
Yeah. And it would just depend on how much increase,
Yeah.
right? Doesn't really tell
That's
you.
what we were saying. It
Which
just
is y'all are
doesn't
really
increase.
thinking about it well. Because yeah, it depends, right? Is it just a little bit? Is it
Yeah.
like so much that you never even
Yeah.
make one?
Yeah. Good job.
You got all those?
yeah. I think we got it. Actually, understand it. Yeah.
Good. Good, good. I know, that's why I keep making you practice them.
If you do this, and you start at the beginning. Can we just do simple?
I watched it just like. Well, that's because 201, there's like almost, there isn't so much feedback stuff.
It's like, what, like 2 or 3?
Yeah, the 202 is like every single system has a few
Yes.
to talk about. Yeah, but I guess there
I gotta
wasn't,
get my mind back on the heart.
yeah. All right, y'all get a excessive, faster.
My brain hurts.
All right, so make sure you got the right answers there so we could go on to the next chapter. So if you block thrombin, that means slower clotting. More bleeding, slower clotting. B, I'd probably say that's faster clotting. C, that'd be slower clotting, because that's part of the intrinsic pathway. And D, slower clotting again. And E, it's not that it's slower clotting, but you break down the clot too fast. So maybe you have bleeding problems. Does anyone know anybody with clotting issues? Either too much or too little?
Like yesterday, I had a clotting issue.
Yeah, what, Russ?
My wife has, I think they call it a protein C deficiency, but if she ever takes estrogen-based birth control and becomes pregnant, she'll have to go on like Coumadin and be monitored real closely. And she has to avoid leafy greens.
Huh. So she has too much clotting?
Yeah, too much clotting.
Yeah. I wonder which one. You said C. I wonder where that fits in there. I have to look that
I know
up.
it's called a protein C deficiency. I have no idea
Yeah.
how that directly affects
Huh.
the clotting.
Yeah, I don't know what protein C is. We'll have to look. We'll have to look into it. But it's something that's pretty common for you to have like too much of one of these factors or not enough or who knows. So what do you think a blood thinner does?
Thins your blood.
I know, that's what you would say. So depending on what you're taking, it could reduce the number of platelets, or maybe it decreases the levels of some of these factors. I mean, there's different kinds of drugs that do that. But it doesn't thin your blood. It doesn't make it more viscous or something. It just makes it not as clotty. It won't clot as fast. I know, well, it's because they call it that, right? Like, of course you would think that.
Obviously, that's the reason.
And yeah, another one of my friends had a baby like 6 months ago. She has something, excess clotting. They don't know why or what factor it is. So the whole time she was pregnant, she had to give herself like injections, IP injections. So intraperitoneal, like every day. Because what she took for her blood clotting, like crosses the placenta, so she had to stop taking an actual pill that she was taking. If you do an IP thing, then it goes right into the blood, doesn't really get to the baby as much or at all. So it's kind of crazy. And that's because in pregnancy, it turns up all your clotting factors. Because you might have a problem. You might need to clot your blood at some point, like if you have a baby, right? Or even during the pregnancy, if something were to tear or slightly go
You
wrong.
get like varicose, a lot of people get varicose veins and stuff. just 'cause
That's
people
isn't that because your blood pressure is going up?
I have no idea. I just didn't know if it was because of the.
I don't think
your veins
so.
are gonna take- I don't know.
You do have more blood though. Your blood volume, blood pressure goes up, so your veins would be fuller. Which would make sense. But it goes away though, right? You're talking about the veins showing.
Yeah.
It goes away
Sometimes.
sometimes.
I think it's more genetic.
Maybe. Well, in some places, it could be the skin stretched out too, depending on what you're talking about, which area. All right. Anyways, what about chapter 20? It's my favorite. What? You want to skip it? So you said if she gets pregnant or takes birth control, right?
Yeah.
Yeah.
Well, that's good.
Yeah.
Control tricks your body into taking it pregnant.
Well, yeah, and it increases. I mean, estrogen increases blood clotting itself, which is why you're not supposed to smoke, right? When you're on birth control too, because that increases blood clotting. Yeah, it even says it on the pills themselves. Isn't that like written on the back? I think I've seen it on there. All right, let's take our quiz then. 20 part 1. Do you know it used to be illegal to send information about birth control in the mail in like 1900? Because it promotes promiscuity. So yeah, there was like some of the feminist leaders like put in jail for sending out letters about like condoms and stuff.
Or like religions or something.
Yeah, I thought that. I think that's pretty funny.
There's a family from my high school that they were super religious, like that they they have like 8 children.
Yeah.
Did y'all need one more? All right, pass those on up. You're done. That's fine. Thanks. You did go to the doctor. Didn't you go to the doctor? What'd they tell you? What'd they tell you?
Not much. Just a cough. They gave me steroids to break it up. Still have a cough, and now my nose is stuffy. It's been like 4 weeks.
No, yes, please. Could I be sick for 3 months,
Like,
please?
throw the sore throat for like a week.
Yeah.
And there's a cough for like 2 weeks. And now it's stuffy nose, and then the cough. I'm like, some more. That's what I told her. I was like, blood cells. They're dead.
Could be.
Yeah, they died.
You're dead.
All right, so I really thought I was going to trick you with the first one, which is at the bottom of the heart. There's the apex.
That's why, because it must be on it.
Because it's backwards. Well, I don't know why they call the base if it's at the top. Doesn't make any sense to me. But then again, that's why I put it on there.
Upside down, and it was like the base. And like, I was like,
Not one of the layers of the heart wall. Epa, myo, endo. They all are. Which valve is located between the left atrium and the left ventricle? Is it mitral, tricuspid, pulmonary, or aortic? It's the mitral valve. And I spelled it wrong, bicuspid, not bicuspic. What about between the right atrium and the right ventricle? Tricuspid. And how about this one? Which of the following holds the tricuspid valves closed? Is it? It's the chorda tendineae.
right when I saw it, I was like, yeah. And I was like, Sorry, I got it right. I won't like tell other people because you already found out.
All right, I'm going to talk all about these today.
Talked about it, remember?
All right, so the heart's a little bit complicated, so you may have noticed. We're going to do some stuff, you'll have it. Because it's really just, if you can start thinking of it as like 4 little pumps. And obviously pumps have to pump blood somewhere, right? So they're all attached to each other or to arteries or veins. So I kind of try to think of it as like a little video, like blood coming in, going through this valve, like following blood cells around. And we'll have a video too of it. But if you can think of it that way, it's a lot easier than think of it as like individual little facts. Like, yeah, we'll see. All right. So we've got 4 chambers, and the heart is a muscle, so each of those chambers pumps blood somewhere. And one place we can start the cardiac cycle is all the blood that's low oxygen coming from everywhere in your body. It's like your muscles, your brain. It all flows back to the vena cava into the right atrium, which is that first chamber. And then the right atrium pumps into the right ventricle. The right ventricle pumps into the lungs. And then what does it do at the lungs, the blood? What does it get? It gets oxygen. And then it goes to the left atrium. Left atrium pumps it to the left ventricle. And then the left ventricle pumps it back to all the tissues of your body: brain, muscles, liver, kidney, toes. And then the blood comes back to the right atrium. So that's the simple cardiac cycle without the valves or the arteries or the veins in there. So you kind of see what each of the chambers do. All right, this is, wait, is this the silly video or the real one? Oh, this is the real one. Whoa. Inappropriate. Ross, can you cover your eyes?
Remember the other day?
Oh, with what? With Ross's brothers? Are you talking about?
No, when they said no, Ross can be the bossy one, and he said, oh, that wasn't sexist.
Oh, right. Yeah. Where's our volume here? How do I get this thing off? All right. Sorry.
Blood from the lower body returns through the inferior vena cava. As the right atrium is filled with blood, it contracts, the tricuspid valve opens, and blood is pumped into the right ventricle of your heart. When the right ventricle is full, the tricuspid valve closes to prevent blood from flowing back into the atrium. The right ventricle contracts, pulmonary valve opens, and blood is pumped into the pulmonary artery and to your lungs. The pulmonary valve closes to prevent blood from flowing back into the ventricle.
Let's back up a tiny bit. So why do we need valves? Prevent backflow, everybody's saying it. Because the circulation is all in one direction, through the heart, through the body. It's all has to go one way. But then again, the blood has to get through. So that's why you use something like a valve that only opens that direction, right?
Some people do have problems where like the blood will go back there because also goes all the way.
Yeah.
What happens?
We're talking about that later today. But it depends. But I guess we can give one example. So let's say this pulmonary valve doesn't stay closed. So then when this ventricle pumps, most of the blood leaves, but then a bunch of it leaks back in. So now this ventricle is going to have to pump that blood again. Or maybe it has to pump harder to start with. So a lot of times what happens is it has to work harder. So when it gets hypertrophy, and then maybe some of the cells start dying. Because you don't want your heart to work extra hard forever.
Valve opens, and blood is pumped into the pulmonary artery and to your lungs. The pulmonary valve closes to prevent blood from flowing back into the ventricle. Oxygen-rich blood from the lungs returns to the left atrium of the heart. As the left atrium is filled with blood, it contracts. The mitral valve opens and blood is pumped into the left ventricle of your heart. This occurs at the same time as the right atrium pumps blood into the right ventricle on the other side of the heart. As the left ventricle is full, the mitral valve closes, the aortic valve opens, the left ventricle contracts, and oxygen-rich blood is pumped into the aorta to reach all parts of your body. This happens at the same time as the right ventricle pumps blood into the pulmonary artery on the other side of the heart. The aortic valve quickly closes to prevent blood from flowing back to the heart. Meanwhile, the atria have filled with blood, and the cycle repeats itself.
So you see how the left and the right side of the heart are like doing the same thing at the same time. So you don't want to think of it as like 4 steps. So it's really like 2 steps. So atria contract, and then ventricles contract at the same time. Right. Where's my little thing? And unplug this. All right, which of the following carries oxygenated blood, or blood with lots of oxygen in it? All right, looks like you've got some discussing to do. All right, so it is E, but which ones is it? It is A and B. So everybody said it's aorta, right? From the left ventricle. So the question is these two. So where does the pulmonary artery start and end up? Does it go to the lungs or from the lungs? It goes to the lungs. So is the blood going to the lungs? Have a lot of oxygen in it? No. It doesn't, right? Where does this vein go from? It comes from the lungs to the heart. So it's got high oxygen blood. And of course, everyone has that backwards because what have you learned before? Arteries have good high oxygen blood and veins have low. Some people have. That's only true of the systemic half circulation. So everything that goes to the lungs is backwards in terms of oxygen. The vena cava is the veins that go to the right atrium, the main large vein that goes to the right atrium. All right, here's a heart, cut in half, transversely. And of course, you'll be seeing this. We've got our pig hearts, or is it cow hearts? We've got some kind of animal hearts to dissect. And it actually does look like that. So the right ventricle, the walls are a lot thinner. And look how compared to the left ventricle, the thickness. Why do you think that is? Oh, LV does stand for left ventricle. I guess that's pretty obvious. All right, so talk group, and most people chose D, but D is not right. All right, so large shift to B, and B is the right answer. Because they all, like the left and the right side, pump at the same time, that means it's going to be the same volume, because whatever amount you pump to the lungs comes back to the left side and you pump it to the body. So you can't have different volumes changing. It always has to be the same. What? Yeah, I guess that would change things a bit. That would be a problem, definitely. And obviously, I mean, how much force do you need to pump blood to the lungs versus everywhere? You need a lot more force. I mean, think about like how much force it must take to pump blood up to your brain. Because your brain takes a lot of blood too. Yeah, I know. It's pretty crazy. All right. Let's see. Let's do. Wait, which question is that? 1 through 3. Where's the one? Oh, let's do 1 through 3. That's with your little cut up cards. Yes.
So is the mitral valve referred to as bicuspid valve or mitral valve now?
I hear mitral valve more.
See, I've heard that one more than in the book.
I know, the book's always calling it the bicuspid. But yeah, most people call it the mitral valve. So, but I felt like I had to put both. Yeah, it just means it has 2 cusps.
Yeah.
All right, so you got those cut up cards. You're going to put them in order, starting at the right atrium. Make sure they're not in order if you cut them up. Mix them around a little bit. And try to do this without any notes or anything. Just have to use your brains.
Okay.
What? Spread them out.
Well, they might already be in order.
We're not putting them in order. I'm just reading. Oh my.
They're all in order. Okay, I feel better now. They totally were.
Were they?
I think.
I was looking for the right atrium, which you said to start with.
Yeah. Right atrium. Oh, it's question 1 on there. On the worksheet. Oh, I didn't give y'all worksheets yet. My bad. What are you talking about? Sorry, you're doing questions 1 through 3. Oh, left atrium. Sorry, left atrium. Is that what I said too? Sorry, I meant left. Right's what we did on the board.
Why do we have 2
Do I?
left atrium?
You have 2 left atriums? Maybe they don't have one. Oh, I know why. Because that's where you're going to finish too,
Oh, okay.
right? To complete the.
Yeah, the cycle.
Give the valve in between those.
Did I really put? Yeah.
Mike, or whatever.
Yeah. So this should be pretty challenging.
And then it,
Y'all are good so far.
So far.
Yeah.
So don't it go the vein? The trunk is
Oh, sorry. Pulmonary trunk is the same as pulmonary artery. I didn't mean to put trunk on there. So it is the same as artery.
I think so. So then where they go down here with
Well, we already have a left atrium.
Well, you're supposed to start with the left atrium. Sorry, that's what it said. Well, just move up, right?
so don't, because I remember the R is the right. I don't know, it's just the way my head is. Stupid, okay?
Are y'all doing?
It's that one. And then it goes
Is there a valve between those two?
Yeah, it's the
pulmonary. No, that's our lungs.
Okay, and then where does the blood go from the left ventricle?
This one's to body.
the right
This one's to,
Before it gets there. It does eventually get there, but it doesn't go directly there.
yes. So that's got here, somewhere on this side.
then it goes to the aorta.
Yes. So somewhere over here.
And then the aorta.
So now we have.
And there's one thing between there.
The valve right there.
Oh, I guess there's 2 things. Sorry. Can we move this?
Right? Is this
Give yourself some extra space. Yes, so there is a valve, and then there's something else, and then there's systemic.
Okay. Oh. Okay, that.
Oh, wait. Okay, pulmonary vein, left atrium, mitral ventricle. And the valve is between, the valves are always like,
Okay.
oh, wait. I had that one wrong, too. Didn't I fix that?
Yeah, we had it like that.
That's weird. I flipped it out. I saw it backwards somehow.
I'm like, what?
Systemic capillaries. Oh, you know what? I don't know why we have 2 left atria. Oh, you were starting with it. That's why.
Well, we have the left atrium.
Yeah.
Tell us to go back to it.
Mm-hmm.
Yeah.
Because we were starting there.
Okay.
So really this would be on the other side.
Oh, okay, because it's left side, right side.
Well, just because that's what we're saying to
Yeah.
start. So you go like this, this.
And then it goes back to the left atrium. So what is that? Okay.
Wait. Yeah, that's right.
Okay. So I didn't do too bad for not looking at our notes.
I know.
And me being half brain dead because I'm so tired.
So honestly, what I would do is mix them all up and do it again. That's probably the best.
I really like that.
Yeah.
We're kind of backwards.
Okay.
We're trying to start maybe the other way to make
We tried to start from like the video, you know, how I went from
Yeah.
right to left.
Uh-huh.
But then we got confused.
And then we're having
Okay.
And there's like 2 of these, so I don't know if we need to use them twice or not.
Yeah, because if you start at the left atrium, eventually you're going to get back to the left atrium. But it's fine. You can start at the right atrium and then move it to fit the left one. That's right.
Okay.
So far.
So
Uh-huh.
back to,
Or these flipped.
oh, yeah, probably, because it's like.
Right.
Yeah.
And you would make sense.
So I think I checked y'all's, right? I think I did. I'll make sure. That's the wrong valve, though.
That goes over the right feature, right?
Uh-huh.
To the switch.
The
Yeah.
valve that I'm just saying is
Aorta. Ooh, this one's not good.
yes, then that would make sense because your valve is what's opening it to the.
So before you get to,
Okay.
there's some things that need to go in there.
That's wrong. We're gonna be like,
Okay, well, it makes sense, so we're still going to, that's our part.
So where's the aorta? Pumps blood to the systemic capillaries.
Yep.
Oh, and then you're there.
Yeah.
So you did have it.
Cool.
Oh, confusing us.
All right.
On the right side.
yeah.
Yeah. Sure. And so then go ahead and do questions 2 and 3 too. After you write that down, take a picture or whatever.
We just stacked those because they're the same.
You didn't want to start at the left atrium?
Oh, sorry, no, we did it in the size of the heart, like if we were looking
Okay.
at it.
All
They're the
right.
same thing.
That's fine. All right. So I'll start over here. Mitral to the right.
Right.
What?
Is that right?
Is that right?
Mm-hmm.
Wow, guys.
I really have to think about these. Yeah.
Oh, nice.
All right.
Nice.
So then questions 2 and 3, and if you would, go ahead and put it in like one long section.
Like in a row.
Gotta go first.
Yeah, so you could like see it all in a row.
That's a lot of stuff.
It is a lot of steps. But honestly, you could figure so much, you can answer so many questions if you can do this. So it tells you where all the valves are, it tells you where all the blood's going.
Is the back open? I guess, yeah, probably should write it.
Wait.
The left atrium would be at the bottom.
And then your left atrium.
Did we? Okay, that's right.
Wait,
No, what are you doing?
no, it's right. Wait, why is it there twice? Wait, hold on, I gotta think about it.
See, he just did this again.
So left atrium, mitral.
But, yeah, that's wrong.
Okay.
Oh, there's where we were. Okay.
There. So what does this one go? Systemic capillaries.
That one goes after. There you go. So that's where like the.
And the left goes under the pulmonary capillaries.
Uh-huh. So it's one long cycle. So
Goes back.
mitral.
So the vena cava goes to the right atrium.
Yeah. And then these are a little bit off. So all the ventricles have a valve between them. So you want to keep the blood from coming back. And then it goes to the arteries. And there's always going to be capillaries between arteries and veins. Because that's where like it gets small and you do like deliver the oxygen or CO2 or whatever.
Blood comes back to the heart. Goes back to the heart. Goes to the right atrium.
And so after you get that copy down, go ahead and put it in one long line. Just like turn it 90 degrees and then do 2 and 3.
Yeah. Go to the heart.
All right, so work on 2 and 3 there. You could just mark it up with the markers.
We're lost.
Did you have,
We feel like we think we got it and then
wait, did you make them out of order? Or wait, did you get them in order
We
already?
had them in order with what we thought, and then it was sounded weird, so
Oh,
it was like this.
okay,
We
let's,
had it like this.
all right.
But then
That's
these should
not
be
right.
together, you know what I mean?
That should be at the end.
But that's where it starts, is that?
I know, but it's a cycle, right? So it should start and end at the same place. So you're really close, though. Actually, everything is all off. I swear you were like almost there before, right? Yeah, so you actually almost had it, and then you like changed everything around and made it like all
So
off.
if it starts at the left atrium, then it goes to the mitral valve.
Right?
Then it goes to the left ventricle.
Mm-hmm.
Then it goes to, not this,
I don't
the
think that's
aortic
the
valve.
Yeah. And then what's after the aortic valve?
aorta.
Uh-huh.
And then from there it goes,
Would it go to the
this is right here. Tricuspid valve.
Mm-mm. So it's going to go to these capillaries here to deliver the oxygen. And then what? Not yet.
I don't know where that goes.
There.
Uh-huh. What does the vena cava bring blood to? Okay. Uh-huh. Mm-hmm.
Or wait, with the veins?
No. Veins always come after the capillaries. And then, boom.
Okay.
Which is fine, because I think you only had like 1 or 2 wrong when I came over last time. Like you, right, you had it.
I think I got confused with the capillaries and the
Yeah.
two capillaries.
Yeah.
I need to.
Yeah. So you were saying,
Am I right? So the right aorta has oxygenated blood, and then the
What about, no, I need like the whole part of it. Because obviously it's not just one spot, right? So like with those markers, you can like circle in red. Like what parts of this have high oxygen blood, and then what parts are in high pressure with a different color. Does that make sense?
yeah.
And that's what I was wondering, is when we, the one with the.
For 2? 3? That's a hard one.
Would it be like the valves and stuff?
Well, which part of the heart puts blood under high pressure?
The ventricle is going to be the highest pressure.
Okay, and then when do you think it becomes low pressure?
When it enters back into the aorta.
When it enters back into the aorta?
Well,
It'd still be under pretty high pressure then.
maybe when it disperses through the body, it would get lower pressure.
Okay, and then what are those dispersing parts on there? What are they called?
No, wait,
The
no, we're up here.
aorta.
No, the aorta would have high pressure. Aortic
And then it's
valve.
systemic
Uh-huh.
capillaries that would
Yeah.
have low pressure.
That's out.
So I would say for the one you just told me then, it'd be from left ventricle to aorta,
Oh,
right? Is that the only place you make high pressure blood though?
no.
So then maybe there's something down at the bottom too, some part of it.
Would it be from the right ventricle to the pulmonary vein?
I wouldn't go that far.
Pulmonary vein.
Yeah.
Sweet. So then those are out.
So the capillaries is where they change from low pressure, high pressure to low pressure.
come speak with us about this.
Which one is this one?
Same as them.
Oh, what about 2?
We did it.
Okay, it's also pulmonary vein though, is high oxygen blood.
This one alone?
No, it's just everything you have plus, oh, and it ends at the systemic capillaries. Because that's where they lose their oxygen and give it to the tissues.
And the vena cava brings it back to, that makes sense, I guess.
Yeah.
Because that's brings back, so should it, okay. Pulmonary veins. Pulmonary veins come out where?
Okay.
From the lungs
Right,
and go to the body. Okay.
yeah. And if you circled pulmonary capillaries, I wouldn't mark you wrong. It's kind of, I mean, it's getting oxygen there, but is it high oxygen yet? It just depends.